Okay, hi everybody. We're going to get started now. I just need to let you know that in case of an emergency, please look around, find the nearest exits. If there is an emergency, we will exit quietly and orderly out the door to the right, down the stairs, and then across the street to Cesar Chavez Park. And then also just to note, we'll be posting this presentation slides after the presentations, maybe next week in case anybody wants those. So let me have Elizabeth Sheely, our Research Division Chief, come on up.
Thanks, Heather. I just wanted to welcome everybody to the Clean Air Leadership Talks honoring the Haagen-Smit Award winners. I think this will be a very exciting event, and I hope everybody is also able to attend the awards tomorrow at our board hearing. I will actually turn it over to Sandy Berg, to Vice Chair Berg, who has been with the board since 2004 and is a very great leader, and I'm very excited to have her host this event. So thank you.
Good afternoon. This isn't one of my favorite events because this event really illustrates the great part of CARB, its leadership, and all of its partners that clean up the air. And we have quite a distinguished group here. We have 7 prior award winners, and I'd just like to welcome them personally. We have John Boyd, we have Michael Walsh, we have Judy Chow, we have John Wall, we have James Boyd, we have Robert Sawyer and Bradley Edgar with us. And so welcome, thank you for being here today. It's really my honor to be introducing 3 very distinguished speakers, and each one, as of tomorrow, will be an official Haagen-Smit Clean Air Award recipient. This award will take place tomorrow at 9 o'clock. Will be led by CARB's Chair, Mary Nichols, along with the board. And we really hope you'll all be joining us in the Brian Scher Auditorium, which is right next door. The Haagen-Smit Clean Air Award was founded in 2001. The award's given annually to those who have made outstanding contribution in the fields of clean air, climate change, technology, and related policies. The awards are named after our first chairman, the late Ari Haagen-Smit, who is best known for linking smog to the automobiles in California. The award recognizes those that have truly followed in his footstep in pursuit of clean air. What strikes me this year about our 2018 honorees is that not only do they exemplify Haagen-Smidt's leadership, but they represent the full spectrum of that leadership through groundbreaking science and research, innovative policies, and working with the public, and then finally closing the loop by unleashing innovative solutions. Each one of our speakers will come up and give a presentation. We'll have a little bit of time for individual Q&A, and then at the end we'll bring everybody up for maybe a little bit of roundtable discussion with you, our audience, and then we'll plan on concluding right about 4 o'clock. So with that, let's kick off with our first speaker. Our first speaker, Dr. John Watson from the Reno Desert Research Institute. As a research professor for nearly 50 years, Dr. Watson spurred many influential innovations in aerosol measurements, source apportionment, and the assessment of adverse impacts on visibility, ecosystems, and cultural heritage. Today, Dr. Watson will share with us his insights on how research and field studies have produced cost-effective emission reduction strategies and improve air quality. Please join me in welcoming Dr. Watson to the podium.
Well, thank you. Thank you. Well, we're going to take a little walk through time to take a look at some of the things that we've learned over about almost 50 years in Central California. We're also going to see some examples of how graphics have improved over that same time period, as you'll notice when we look back at some of the more ancient material. So I'd like to really kind of look at why California is one of the best air quality research opportunities in the world. It's a laboratory, and it's a laboratory that other people are taking advantage of in other countries as well. We're going to look at the evolution of knowledge and then identify a few of the challenges that we still have here. Now, if we kind of look at the types of publications and reports, and I keep a pretty good record of these, although I'm sure it's not complete, you can see that Central California follows only Southern California in terms of the numbers of reports and publications that are out there. And it's a continually expanding knowledge base that we have on this, too. You'll also see that there are other places in the world that have similar types of problems, and they're also expanding. I think the important thing that I found in working in places like the Indo-Gangetic Plain and in central China, around where Xi'an is, the first emperor of China is buried there, is that many of the things we've learned in Central California give us hypotheses that need to be tested in these other countries. And the reason is because it is so diverse and it has so many different things. You've got the Central Valley, you've got the mountains, you've got the coasts, all of which make a big difference in terms of the pollution. Not only that, we have all the different types of sources, or have had all the different types of sources. We've had high sulfur emitters. We've had transportation. We've had industry. All of these are very important things that have affected pollution, but also have been controlled, that set an example for the rest of the world. Now, I'm just going to go through this very rapidly here. This will be available if you want to take a look at it. If you send me a note, I can send you a complete bibliography with this. But I want to just point out kind of the history of how we've gone through these different types of things. I got involved in Central California probably in about the late 1970s, 1979 or 1980s. We had our first speciation network, the EPA Inhalable Particulate Network. And what struck me was that Bakersfield at that time had the highest sulfates, 60 micrograms per cubic meter in Bakersfield, the highest sulfate measured in the entire network across the United States. When I came back to the West here, having lived back in the eastern United States and being glad to get back to this part of the country, I got involved in different projects with the ARB, with the Western Oil and Gas Association, which is now WISPA, to really look at some of these issues in greater detail. And these led to a number of these different large field studies and many smaller ones that took place over the subsequent 35 years. And you can just see kind of an example of all these up until some of the last organized studies that have taken place within just the last few years. Now, California's made tremendous progress, and you can see that in both the 24-hour averages and in the annual averages for particulate matter. And particulate matter is really the most important pollutant right now. Ozone's also important, but they're very highly related because many of the sources, particularly of the nitrates that we have that are in Central California, are also the issues that affect the ozone that happen there. But you can also see that though we made progress, we seem to be stalling out a little bit. Well, one of the first things we noticed was that the PM 2.5 is really a wintertime problem. This is really what's driving the annual average. And this is the graph that we plotted out when we planned our major study for 2000 that really verified how much the winter is really an issue. And that's where we have focused much of the efforts over the past few decades, is really trying to understand the winter issues with respect to it. And what happens in the winter, and it's quite variable, is we get these high pressure systems that set up that are blown away by intermittent storms. This year, we haven't had very much time to have those things because we've just had one storm after another. But you'll recall earlier in this decade, we had like 5 years of drought. And during those periods, we had these high pressure systems that would set in for weeks at a time. And this led to really a lot of accumulation of the materials. But what were the sources? And what was the way to solve these sources too, to control them? That was kind of the questions that came up at that time. Well, one of the earlier studies, and a good example of what the graphics printout looked like in those days, was really the first source apportionment study that we did in 89 and 88. And this really did identify in the southern part of San Joaquin Valley the large sulfate, and given the markers for that, the vanadium, the nickel, it was very clear that it was the burning of the residual oil that was brought up from the oil fields. These oil fields were 100 years old, and so the oil was very thick, and they had to create steam to get it down there. Now, one of the important things about this type of study is that it involved the oil companies. And they were not averse to making the changes. They just wanted to know that the changes would make a difference. And so as a result of this, they switched from burning the crude oil to using natural gas for that purpose. And later on, when we found out that NOx was a regional issue, not just a local issue, they also put on the SCRs on there. And I think that's really one of the important aspects of these studies, is that once the evidence is there, it gives the industries not only the justification, but the motivation to step up and do what needs to be done. One of the important findings at that time was that the sulfate was not formed as it does in the eastern United States through long-range transport, but it was forming through the fogs that formed, the vast Thule fogs that we used to have in the Central Valley here. And this was an important aspect, too, because we had a lot of those fogs where the sulfur would enter into it. And this is some of the Caltech work that Michael Hoffman and his students did that really kind of laid out the whole idea of why we have to look at fogs as a reactor. And this was now accepted pretty much, but at that time it was not really very well known. After the controls were put in, we saw a major difference in the fog composition. That we saw that it changed substantially from the sulfur in the fog to having more nitrate and other types of dissolved things. And in fact, once it was not acting as a reactor to create sulfate, the fog actually turned out to be a pollutant remover because it would create larger particles and these would deposit back to the surface. One of the other issues that came up was just how regional is the problem? And where should we focus our pollution controls for different parts of the Central California? Because it's a huge area. It's bigger than many states. It's bigger than some countries. So this was kind of the focus of our 2000 study, where we put out a very dense network of particle monitors. And you can see, of course, that we had major clouds in the wintertime, but there's some separation in between them when we just look at the mass concentration of those clouds. We also see some hot spots in other parts of the year as well. So what was the cause of that? Well, if we looked at some of what we call our anchor sites in the chemical composition, we found that the carbon material and the nitrates were really where the issue was. And this is a little bit of an issue too, because these are not necessarily directly emitted. The ammonium nitrate doesn't come right out of a smokestack or out of a tailpipe. It forms in the atmosphere. And it only forms when you have ammonia present as well. So we need two pollutants there. The carbon is also an issue, not only because it comes from many sources, diesel, gasoline vehicles, and other things, it also forms from gases that are emitted into the atmosphere. So this is kind of the puzzle. We knew what the major pollutants were, but what are the sources of those pollutants? How would we get at those, and what was the most optimal way to control them? Well, one of the big issues was this issue of whether or not we have ammonia or nitric acid, which forms some NOx, controlling it. And you can see how these isoplests work. And for those of you that are acquainted with the EGMA plots for ozone, these look exactly the same way. For example, if we reduce ammonia along the horizontal axis, we don't see much of a change for a long time. But if we reduce the nitric acid, which comes from the NOx, then we see a rapid change. So the upshot is that there's a lot of ammonia in Central California. There's a lot of it. And one would have to go really hard. One would have to reduce it an awful lot before we got any control. So this would suggest we got to go after the NOx. We got to go after the NOx. But do we have to go after the NOx? Because there's another complication here. And that's because just as with ozone, the nitric acid forms by a combination of VOCs and NOx. So what's the limiting factor there? Well, this was a controversy for a while because our data were mostly focused in the cities. And in the cities, we just have a lot of NOx. And so one of these original studies had suggested, we're VOC limited. Because we have so much NOx in the cities, that's the case. But the fact is, if the nitrate is forming, not just in the cities, but elsewhere, then we may have a situation where we are NOx limited and not VOC limited. And in fact, that turned out to be the case. Once we looked at a broader scale, got out of the cities where our compliance monitors are, and looked at what is happening between the cities and the countryside, this was very evident that the NOx control would be important. Now, that's also important for ozone, and this was a very important finding because we can control VOC or NOx for ozone as well. And pretty much we've decided on a NOx control that we've demonstrated in Central California that NOx needs to go down. So if it was VOC, we would be counteracting our ozone and our PM strategies. But as it is, we kind of lucked out in a way because they're good for both. And of course, once we developed the models, particularly the work of Mike Kleeman at UC Davis over here, became very evident that we would get a better type of reduction if we went after the NOx. But how did the NOx get together? How did it get together? How did it come together with the ammonia? Because the ammonia comes from outside the city, and the NOx comes from in the city for the most part. Well, if we look at the meteorology here, what we see is we have a very low mixed layer at night. And it's only after the sun comes up during the day that we get mixing at night. And when we do vertical profile measurements, we can see that even though wind speeds are low, and particularly low at the surface, it's practically stagnant, we do see some sluggish movement aloft. And one of the things that brought about our understanding of how these two come together was the advent of new measurement technology developed by Suzanne Herring out here in Berkeley that allowed us to look at very rapid nitrogen nitrate measurements. And you can see here, right in the morning here, if you look at that curve there that's labeled, you'll see how the nitrate, as the temperature goes up, all of a sudden it shoots up. All of a sudden it shoots up. And it does that because the surface layer is then coupled to the layer aloft. So what this meant was we were getting, during the daytime, we were getting the NOx and we were getting the ammonia from different areas mixed up aloft. Then the inversion set in. And these would move around the valley. They'd move around the valley and come together. And because we have a nighttime mechanism to form nitric acid, the nitrate formed aloft and then boom, mixed right down to the surface. And you can see it doubling right there. And we tested this out with a 100-meter tower to demonstrate that yes, when the nitrate aloft went down, the nitrate at the surface went up. Now, what did this suggest? This suggested that the nitrate is a regional phenomenon. Everybody's got to participate. It's not something you can just do in the city. Everybody, all the NOx emitters have to participate. And that's where the opportunities come to reduce the pollution. Now, the other issue was the organic carbon. And you can see here in the wintertime that tends to be focused more in the city areas. You can see it around Fresno in the summer and the winter. You can see that, that kind of a hot spot that's there. We had some good work done by Glenn Cass and his graduate students who really identified that it's not just diesel exhaust. It's not just gasoline exhaust. It's not even only residential wood smoke. Those are things we knew about. But we also came up with other things like cooking and secondary organic aerosol that were important aspects to it too. And I think this is another thing, is that every time we approach a problem, we find that we go back to our emission inventory, and yet we find there's sources we left out. And in retrospect, it seems odd. Gee, I should have thought of that. I became aware of this when I was doing my graduate work in Oregon. We did not have paved road dust in the emission inventory. We only had industrial sources. There was no wood burning in the emission inventory. And so people didn't think it existed. It was only through these types of studies that we kind of hone in on what's there that we don't know about. This was kind of verified by looking at certain organic markers. In this case, it's a sugar called levoglucosan that is very unique to vegetative burning, to biomass combustion, that makes a big difference. And you can see how that is much larger in the cities than it is in other places. Now, one of the important things that we're seeing too is also the evolution of our more routine measurements as they come along. We have two speciation networks, the chemical speciation network for urban areas and the improved one for non-urban areas. And we've kind of been going along with these for 30 years, particularly in the case of Improve, just measuring elements, ions, and carbon fractions. Well, we've taken some steps now to innovate with this and started to get what we call multi-wavelength carbon here that measures something we call brown carbon. And brown carbon is an indicator of biomass burning. It comes from the smoldering. And this can be very useful when we're looking at exceptional events, and particularly for natural visibility conditions that are related to the regional haze rule. And you can see an example here from the car fire, where the brown carbon fraction really is very evident from these measurements. And the nice thing about them is you get the same measurements you had before, but you get these measurements too at no extra cost. It's really the same procedure, just a modification of the instrumentation to help us get that. And these information have been acquired now since 2016. There's still some issues that are coming up that are rather interesting. This is an interesting paper that came out a couple of years ago that kind of caught my eye, because you remember how we saw the nitrate go up when we had the mixing down. Well, this one finds that we have the oxygenated carbon is going up in the same way. And I kind of pointed out there where the indicator, the oxygen to carbon ratio, goes up. This is an indicator of secondary organic aerosol. Now, this is still speculative, but it may mean that just like the nitrate, we're getting gas to particle conversion of the organic material aloft that's also mixing down the surface. And I think this is one of the things we ought to be looking at in the future. I'm not going to go through this list. I'm sure it's not complete, but I like to show this list to people in China and in India to basically tell them, you can do it. That it's been done in California, that the knowledge was there, and probably there's a lot of the same things going on that you can find out if you look for them, and that here's the things you can do, and here's the things that have been shown to work. So I think ARB should be very proud of the leadership it has taken in this area to really try to not only clean up California, but to serve as an example for the rest of the world. Now, where do we stand now? This is a plot I did on the latest measurements from Fresno. That's been kind of our super site, kind of our touchstone for the whole Central Valley. But I did other ones. They're similar. They look similar to this. And you can kind of see that the nitrate's gone down, the carbon's gone down, the sulfate has gone down. So there has been progress here. But you see that after 2011, we see more of a fluctuation here, don't we? I mean, some years are good and some years are bad. Remember, like 2000 through 15, those were drought years. So we probably had more of those high pressure systems that were in there, and we had more accumulation of these situations. 2016 was kind of a wet year. 2017, last year, we were dry, except we had late rains in March. This year's going to be low because we've got storms all year. So we're entering an area where, you know, we're not sure what's going on. Our meteorology definitely affects us, but you can kind of see it's fluctuating. We may go back up, we may go back down. Let's not forget the fires, too, because you can see the organic carbon fluctuates a lot, and we know we've had a terrible fire this last year. Well, I think the important things here are here. I won't go into detail on these here, but I think another thing we try to get across when I give a lecture like this in another country is you can't blame it on just one source. You know, everybody's kind of get in there. And it's a multi-pollutant problem, too. It's not, particularly for particulate matter, you can't just go after the dust, you can't just go after the exhaust. You've got to look at all these different pollutants that are interacting at the same time. Are we done yet? Do we know everything? I don't think so. I think one of the most important things is how climate change is enhancing or negating our emission reduction measures. That's something we really don't have a good handle on. Also, we're working with nearly 20-year-old data. Our last big study was 20 years ago, and the chemistry may have changed. Maybe what we think are limiting pollutants then are not necessarily the case now. So we have to be continuously thinking about what comprehensive studies we need to move forward. Now, I'd like to acknowledge the people who I have learned from here and the people who have contributed to this. And many of these people are as deserving or more deserving than I am for this honor. So I would really like to recognize this. And you'll see quite a few names in here from ARB as well, and a few people in the audience here that have contributed this knowledge and deserve just as much recognition as I do for this. So that concludes my presentation.
Oh, wait, hold on. Let me get a mic first. Yeah. I want to enter the mic.
I'm wondering if you want to say a little bit more about the fires. I remember when we had 10 years ago the Angora fire at Tahoe, we thought we were going to start doing things for fires, and they're just getting worse and worse. Are they making a significant or less than significant impact on air quality in California?
Our analysis suggests that they're important. We're hoping to analyze these brown carbon data a little more detail so that we can see where and when and with what frequency that happens. We haven't had, our routine measurements aren't that specific to the fires. But we all know from our experiments, I mean, I got bronchitis after the Rim fire came up to Reno. I mean, we've had these terrible fires in Redding. I heard that Bay Area and Sacramento, because of the Carr fire, wasn't it? Didn't you have an alert here? So we know that these are having an adverse effect. What to do about them, I think, is a challenge, and that's I think, a challenge for you folks as well as people in the forestry people.
Thank you very much. We'll have another opportunity after we're complete with all three speakers. We'll bring everybody back up and have another opportunity for some questions. Our next speaker, Dr. Barry Wallerstein, is currently a senior policy fellow at UC Riverside School of Public Policy. He served as the executive officer for South Coast Air Quality Management District for nearly 20 years, where he oversaw policies and programs that achieved dramatic improvements in air quality against a backdrop of strong economic and population growth. And as a Southern California girl, fourth generation, I can attest to the 60s. Where we couldn't see the mountains. And as a business owner, I can attest to the fact that I was a regulated business and how important it was to formulate products and things. And South Coast Air Quality Management District was the leader. If you could have your products be within the South Coast Air Quality Management District, those products were sought after. And so I appreciated Barry and his team's leadership on that. Today, he will share how further integration of air pollution control programs with global climate change programs are critical to save our environment and protects everybody's right to breathe clean air. Barry?
Thank you for that lovely introduction. And first thing I want to say is what an honor it is to be here, to be part of this, and to be receiving one of these awards. It really means a lot to me personally. Well, it worked when we tried before. Well, this is what the air used to look like. So what I'm going to do is I'm going to talk a little bit about the history, and then I'm going to talk about the lessons learned, and then I'm going to mention some priorities that I think are important as we look to the future, because I believe the more than 50 years of progress really tells us and gives us a window into what needs to be done in the future. So this is a Time magazine cover from 1967. It happens to be the year that the California Air Resources Board was created. And of course, when you can barely see LA City Hall to the right of the photo, that peak, from a few blocks away, it speaks loads about how far we've come, especially if you look at a beautiful skyline of Los Angeles that looks like this. So it's 50 years of progress and healthier lives for the people in Southern California, but this has been duplicated to differing degrees throughout the state. That we like to talk about indicators, and I could spend more than my allotted time going through all the indicators of success, but a couple that we like to highlight is the traditional stage 1 and stage 2 smog alerts that were up in the over 239 and now have been at 0 for a number of years. Black carbon being reduced by 90%. And if you look at the other key pollutants, they've all been reduced by a large percentage, including the carcinogenic substances that are in our air. And as been noted in previous comments, if we look on the at the chart on the right, we've accomplished this with a growing economy. And as many of you know, the California economy worldwide would be ranked as the 6th largest. So this notion that you can't have clean air, you can't clean the environment, and at the same time have a strong economy is proven false by the actual data. And so we have to keep that in mind as we go forward, and I'll mention that. Now, we can show you all these air quality measurements, but where the rubber really meets the road, excuse the pun, is what happens with public health. And the Air Board staff had worked with researchers at USC and funded work at SC along with others, including the South Coast District, for a children's health study, tracking children from kindergarten through high school and looking at how their lungs developed and what were the impacts of air pollution in the more polluted areas compared to some control areas. And as shown for you on this chart, the key pollutants they were looking at in terms of public health and the growth and function of the lungs of the kids were going down by large percentages during a 12-year period that's reflected on this slide. And when you do the numbers, basically what it says is looking at the kids with the most significant deficit relative to the functioning of their lungs, over that 12-year period, there had been a 57% decrease in the number of kids that suffered from that level of severe impact on their lungs. That, to me, is the indicator of progress. So, as has been mentioned before, those of us that are in this profession, as many of you in the room know, we do get these questions that are up there. I can see the mountains now, my eyes don't water, my lungs don't hurt, the air doesn't typically smell, and these comments aren't coming from people that live in the environmental justice community, so I just want to point that out. So the question we get asked really, isn't this good enough? And I then turn to, what does the science tell us? And what we know is that the notion that some had when I started in this field nearly 40 years ago, that we were going to work ourselves out of a job. The air would be clean, we wouldn't need so many people, you better think about what your second profession is going to be because you don't have job security. Well, of course, that's an objective that we all liked and would have loved to have been what happened. But what we also know about science is the more you know, the more you realize what you don't know. And so it changes over time, and you take on new studies to get to where your ultimate goal is. And so when you look at a word cloud like this, and we think of climate, and we think of tightening ozone and particulate standards, and we think of air toxics and so on, what we know is the job is really far from done. So for those of you that work in this building, in the airfield, rest assured you'll be able to retire in this field. So when we now turn to the challenge of the 21st century, the way I like to think of this is like two bookends. We have climate change on one end, and now we have environmental justice, equity, and severely impacted communities on the other end. And this is different than what has been really the tradition in air pollution control, because years ago we would cite our monitors to be representative of sub-regions, not communities. We would cite them away from key pollution sources like a refinery or a freeway so that it didn't impact too heavily the sub-regional monitored levels. Today, the rules have been changing, and under a more recent Assembly Bill 617 by Cristina Garcia, the world is really going to change for those of us that do air quality studies. Hung up again here. There we go. So, the way I describe this change is refocusing of our efforts. And so if you look at typically what had been done, we do regional plans or state plans like the scoping plan for climate change, or like the state implementation plan that embodies the regional clean air plans in one document along with the state's efforts on mobile sources and consumer products and things of that nature. And those statewide plans are complemented by efforts at the local level, including regional transportation plans and so on. But now under AB 617, there is a mandate to develop in the most severely impacted communities a community-based plan and to do community-based monitoring in great detail and to take a number of actions to help clean up those communities. So we have a feedback loop from our two bookends. It isn't going to be just what was generally the past process of top down, but now it is also bottom up. And the beauty of it will be that in the end, the two bookends will help each other and everything in between, which is our regions. So we will all benefit from this effort. So in my mind, if I was at CARB instead of being at UC Riverside, and I was thinking about all this, I'd say, wow, I have some really difficult questions to answer if I'm on the staff, or especially for the governing board members here at CARB or at the local districts. So number one to the left of the slide is, we want to maintain this leadership. Leadership means you can have better control over your own destiny and help others to reach consensus with you and join together. And when we're dealing with climate change, we are talking about the destiny of the planet. So you want to be able to impact the planet's destiny by providing examples that can be adopted by others, as John indicated in his slide that listed many measures on particulate control that could be beneficial elsewhere. We also, as I mentioned earlier, want to keep the bond between strong economy and what we're doing to clean up the air or address climate change, because they can feed off of one another and give us more perpetual success than would otherwise occur. Environmental justice is going to be central, along with equity, as to being able to move forward and garner the public support, the political will that's going to be necessary. And we're going to have to really work hard to think about how to deploy our resources and to set priorities, because the task is so big. And even though we have lots of resources right now, we can't always count on that. And the level of work that's needed really at this point in time even stretches beyond our resources. I've also highlighted on this slide what is an area I've been thinking a lot about lately, and that is the area of communication and how we translate what are increasingly complex scientific undertakings and what the data means and translate it into public policy. I attended a climate conference last May, and I was struck by the fact that most of the people in the audience, frankly, aren't going to be around in 2050, and certainly not in 2100. And so how were they going to be thinking about something I do today is going to not only affect the next generation, but the generation after that, and so on. And so how we do that is really going to be important. This slide lists what I'm calling core principles. They're what I think are lessons learned from our efforts over the 50-plus years. And you see the first item I've listed on the left of the slide is credibility. That combined with the second bullet, fact-based decisions and science-based actions. You have to stick to the science. You can't be shy about telling people things that they may not want to hear, but that it's necessary for them to hear to make the right decisions. And for those of you that are on staff, credibility in my mind is the #1 trait of a staff. Again, listing environmental justice and social equity and the economics and the political will. But the right-hand column speaks to integration. There's been a great deal of that that's been done in recent years across environmental media and from the federal, state, and local levels. But much more needs to be done. And it's complicated more at this time because you have the two bookends and the traditional in between. There's lots of commonality where you get co-benefits, but there are also instances where you get disbenefits. And so that has to be laid out in a way that everyone can understand why the decisions are being made and the priorities are being set. And again, communication and personalizing so people understand what the impacts are. So someone like myself, of course, I have training in this area, but if I didn't, that I understand that if I'm emitting more from my vehicle today, that is going to affect my grandchildren. And my twin granddaughters, if they have children, it'll affect their children. This has to be continued to be a personal issue, just like when we couldn't see mountains and our eyes watered and our lungs burned. So fortunately, we have many proven tools. I've only listed a few in this word cloud that we can draw on. But it's quite clear that we're going to have to add to that toolbox. We're going to have to do some of the old tools in new ways and invent new tools to be able to tackle the problems we have. And we're lucky that we've approached things in the past and learned not everything has to be command and control. Some things can be incentives, and some things can be kind of combinations in a sense that they provide flexibility, like a cap and trade program. So when we use these tools, there has been some adjustment to the way we've approached this over the years. We now recognize that you have to begin the engagement at step 1, not partially through a process, that the input that you're receiving from local constituencies and stakeholders has always been important, but you have to strive, if you're on the agency side, to make sure you are trying to walk a mile in their shoes to fully understand and react and make changes as appropriate. We also want to break down these complex issues into what I call digestible chunks so that we can customize things, come up with general elements that can be used in other like situations so that we have building blocks we can move in and out to create our cleanup plans. And it has been long established that if you have deadlines and you have consequences and you hold entities to the consequences, you will make the progress and you'll make it sooner than you otherwise would. So I also think of the current situation as like a book with chapters. And we've had different chapters in the book, and now, at this moment in time, we're embarking on a new chapter. This Community Air Protection Program in AB 617 is going to be one of the themes in our new chapter. We're going to have what I'm calling advanced monitoring and sensor technology from A to Z. what has happened in that particular discipline and field is really, frankly, amazing in terms of lowering costs. So you can have a huge number of sensors in a small area reporting data, and also more sophisticated things like fence line monitoring or flyovers of an area taking pollution readings. And in fact, that's exactly what's being done in the South Coast District as part of the initial AB 617 program. We also know that once we collect all this data, it's going to be one heck of a database, and you have to analyze it and be able to display the results in an understandable manner. So what is occurred in the world of GIS and having greater computing power, as a side note, I'd mentioned back in the day when I was director of planning at South Coast, we used to rent time on the supercomputer at UC San Diego because it was taking us so long to run our ozone attainment modeling that we couldn't turn things around fast enough. Nowadays, of course, people can, I guess, run it on their desktop and be able to do things more efficiently and effectively. So we have to be able to deal with the big data question. And we have to be able to rapidly implement these community-based measures that are intended to address environmental justice. Investments and incentives are going to remain important, but one of the things that I think we can do better at is technology workforce transition plans. If we look at something like vehicle automation for truck drivers, that someday could mean there aren't as many truck drivers' jobs. What are we doing to transition? How are we pre-planning so that there'll be another job for those individuals? And on the technology front, as technology advances, do we leapfrog over a technology to another technology and still meet all of our objectives and goals? So we have to think about this in great detail. And we're going to need additional funding, and we're going to need creative financing. There's 3 revolutions in transportation technology that are occurring now that are going to have a significant impact on our climate change program and our local air quality programs, because the transportation sources remain one of the major source categories that we need to do better at. And so vehicle automation, shared mobility, and electrification have to be integrated, and we have to figure out how to better embrace what is happening and help steer what is happening so it helps us with our environmental and mobility needs. This next chapter is also going to have some activities for local government. This has long been an issue in our clean air efforts because cities and counties have their own special authorities about how to create livable communities, and we want synergies. We want to be helping them, and we want them to help us. And the good news is that we now have a requirement, for example, to put environmental justice in the general plan of cities or counties, either as its own separate element or integrated into the other elements. And the same thing is true relative to air quality elements, which then trickle down to zoning ordinances that help us appropriately not put people too close to sources they shouldn't be close to, as well as helping with the nexus between transportation and air quality. In technology advancement, nowadays we have incubators, and we have still have a core of venture capital activity in the state of California. This has been tapped to a degree, but it's 2 resources that I think can be tapped better. I would suggest if CARB isn't doing it, that they consider putting on a symposium, maybe every year or every other year, to bring the parties together to describe what's needed and in these plans for the future. Scalability is incredibly important when we talk about climate change. If we're a wealthy state and we can fund a large number of vehicle turnovers and this technology and that technology, that's great for helping to show it's feasible, commercial, and can be done. But we have to think about scalability in climate so that some of the things, if not the preference would be most are actually transferable to countries or regions or areas or communities that don't have the financial resources we do. And I believe one thing we can do is broaden our purchasing power that we have. The South Coast District used to join the state of California in fleet purchases, and I'd get a better price for my fleet. I think if we're not doing that, we should be doing that, low-cost sensors and other things with other regions and states that want to move forward in similar activities. And again, communication and fluency, the state has done work in this area where schools are now getting a curriculum that they use for climate. This is something we need to do more of. And again, personalize information. But the last one is one that I think we can do really a lot better. But I first have to say the CARB webpage is beautiful and functional and easy to find information and get good information. But if we think about what we've watched happen maybe on the national scene and how social media has been misused, but is the tool to get to a lot of people, then we have to think about, and government has to be careful because we don't take political positions, we provide information, but we have to think about how to better use social media, including videos by various means, so that we can educate people and just provide the science. And the National Academy of Sciences just last month put out a report that is their guideline for the academies, medicine, engineering, and science, on how to provide information on climate. So I would recommend a peruse of that document as something that could be very helpful. My final thoughts are speak truth to power. That's critical. And protect our current authorities and try and expand them. The federal government has moved to limit us in climate, to limit or take away the state's mobile source control program, which is an absolute gem relative to the progress we have made. And I'm concerned about now we're embarking on community-based activities that somehow they may try and do that as well. Governor Newsom last December, before he took the oath of office, said, well, what about getting rid of diesel pollution by 2030? If we could do that, that would make immense improvements on a whole lot of fronts. And then relative to EJ and the communities, I propose two things. One, no backsliding. We're not going to let the worst communities in the state relative to air quality slide backwards. And secondly, the further behind you are, then the faster the progress should be. So as we design those plans, we should think about those two elements to be reflected in policy. One that I have to mention, I was working on it before I left the district 3 years ago, is near zero and zero emission NOx standards for heavy duty trucks. The CARB staff is working on this. For ozone and particulate, this is the #1 thing you could do, and it also will help us immensely in other regards. Then this rapid integration of new data, computing power, artificial intelligence, and analytical tools. This is something that we're working on at UC Riverside. We call it Dynamic Mobility Management Systems, or DIMES. We're going to have a plethora of low-cost sensors plus more complicated devices providing data into the database. We're going to be able to process that data. We'll be able to use artificial intelligence, and we'll be able to connect to mobile sources and adjust how they operate at various times and in various places. And this will give us a real leg up relative to pollution control. I'd like to now end on a quote from JFK. The risks and costs to a program of action, there are risks and costs to a program of action, but they are far less than the long-range risks and costs of comfortable inaction. I think if we can all take that to heart, then we can make the kind of progress that is needed. And thank you.
talk a little bit about how you see the domain of the environmental justice playing out? I mean, it's pretty straightforward when, at the very high level, when all engine production gets regulated on January 1st, you just got to change it for everyone. And then, and of course, we occasionally had conversations like, can you actually talk to Tom and Chet and just give me one number that I have to add? But I can imagine with the communities, to the degree that it's driven locally, then you could really have a tower battle out there giving direction to what we need to be doing from a regulatory standpoint. So I mean, I've been thinking about that as long as I've been listening to you, and you've been thinking about a lot of that. So how do you manage it?
Well, I'd like to point to two things as to why I think that we can address issues like in a committee. Okay. So if we look at the ports of LA and the port of Long Beach, that was and is still a toxic hotspot for the surrounding community. And what was developed in response to community complaints and desires of the Air District and South Coast District and so on was a change out of the fleets. First to put on particulate filters, which would control the toxic risk to a very great deal, and then subsequently for NOx control. They planned to change out those fleets in 5 years for the drayage trucks. It was done in 3. That's a community-based program that had benefits, co-benefits for everyone that lived along the freeway or lived adjacent to the communities that have warehouses. This DIMES program, or we have another program that I'm actually working on that's funded by CARB, is looking at whether or not we can adjust engine operating parameters in certain communities, send a signal to the engine, and be able to do that in a way that reduces pollution, but also provides adequate performance. And we would obviously, we're looking at fuel penalties, if any, that would occur. So taking sensors, the ability to transmit information from the vehicles to some sort of instrumentation and back to the vehicles, it's not necessarily the easiest of tasks, obviously, as you know probably better than anybody in this room. But these are things that are now becoming available for us to do. And so I believe we'll be able to develop on a more fine scale what's necessary. Okay, thank you.
That was a great lead up to our third and final speaker, because now it's about solutions. And our final speaker, Mr. Hal Harvey, is the CEO of Energy Innovations based in San Francisco. He is known for his pioneering energy and climate philanthropic endeavors. He founded the Energy Foundation and Climate Works Foundation and started the International Council on Clean Transportation, just to name a few of his accomplishments. Today, he will discuss innovative policies and strategies that do the most to transform our grid to zero carbon, make our vehicles zero emission, drive buildings to zero net energy, and switch to zero waste manufacturing. Please welcome our final speaker, Mr. Harvey.
Well, I am deeply aware of being surrounded by my betters here. It's a real honor to be here with so many leaders, and so many people have been mentors to me since I got into this business, I hate to say it, 30 years ago. So when we started the Energy Foundation. I do want to talk about solutions today. The climate problem has certain characteristics that commands a certain response. It's not a business in which we can dilly-dally around, and it's not a zone where all ideas are good ideas. Solving climate change is such a hard problem and so fast upon us that we have to do the right things. We have to do them promptly and we have to do them thoroughly. I always look at speed and scale.
Toward that end, two colleagues and I have written a book recently out called Designing Climate Solutions, which you can get anywhere books are sold. And if you have any trouble getting them, let me know and I'll make sure you get one. We did this for a reason. When people talk about climate change, first you're inundated by a wall of problems: sea level rise, extinctions, extreme heat, extreme cold, droughts, and so forth. And then you hear a long list of plausible or semi-plausible technological ideas that can fix this. We can all go vegan. We can invent fusion. We can have better efficiency standards. We can have windmills and solar everywhere, and so forth. It's hard to sort through all those different ideas. And then to complicate matters further, there's a whole host of possible policies you can pursue. You could start a green bank. You could divest your university endowment. You could launch a renewable portfolio standard. You can clamp down on vehicle emissions, and so forth. The problem when you have such a the issue when you have such a complex set of problems and so many solutions ideas is that people just kind of do a little bit of everything, and that will not work. What I want to do today is quickly, because people here are expert, is walk through some of the characteristics of the climate problem that force you into a pretty focused solution set, and then talk about that solution set. So, it works. The first characteristic of the problem that not everybody understands is that the extremes become the norm. The way we experience climate is not with average changes. That's for modelers. They needed a convention to hook all the models together. What we experience are the campfire, right? Or the flooding that takes place. This is kind of an ironic explanation of climate change as the sea climbs over the wall in Boston, Massachusetts. Droughts, floods. Here's a picture of recent temperatures. This is when all the news was going on about the cold, incredible polar vortex in the Midwest. And it was cold. It was 40 degrees below zero in Chicago. But if you look on that slide, there's a little blue spot that's cold, and all the rest of the globe is hitting record heat for the month. And the polar vortex reaching down into Chicago is itself an example of climate extremes, because we're losing the energy that isolated the polar temperatures from the temperate climes. We're losing the energies driven by temperature difference, and the north is warming twice as fast as the rest of the world. So that curtain of air, that barrier of energy that kept those cold temperatures out, is softening, and so now we have these big lobes. A high lobe is what we had recently in California, the drought, the so-called the RRR, the ridiculously resilient ridge of high pressure system. That was the opposite part of a lobe. It's the same phenomenon going on. So the extremes become the norm with the drought. This is a picture of Thailand. There have been times when half of Bangladesh have been underwater. 150 million people live in Bangladesh. They're not surrounded by friendly countries. The second characteristic we have to remember is runaway feedback loops, and there are a lot of them. The one that scares me the most is this one. The entire tundra across Russia, northern Canada, Alaska, is filled with frozen methane and also carbon that's trapped in the ice. When you defrost that ice, it releases it. And if that happens at scale, humanity has no physical way of controlling it. And it can add a couple degrees just by that alone, right? So that's a tipping point. That's the scariest one, but there's others as well. Wildfires themselves release a lot of carbon. They create a lot of smoke, which brings in more heat, and they can basically accelerate climate itself. The Arctic sea ice is melting, so instead of a shiny white surface that bounces the sunshine off, we get a dark surface that absorbs heat. There are about half a dozen or more significant instances in which nature simply takes over the job, right? We kick it off. We do our bit as humans, and nature accelerates. So we're at a meta-stable place, which can slip into runaway. Some elements have already gone into runaway. Ice melt is now in runaway form. The melting is faster than the science. The scientists don't know how to track it, and they don't know how to calculate it, and they don't know what's driving it. It's gone into runaway mode already. Okay, all that horrible news. Couple more characteristics that are important. When you put carbon dioxide in the atmosphere, it stays there. Its half-life is millennia. And what that means, the consequence of that is what we do is emissions, but what is done to us is concentrations. You do emissions once, you get concentrations forever. So look what that means. If you have runaway emissions, you get ridiculous, crazy concentrations. And even if you stopped those emissions, went to zero, you would stick with whatever concentration you were at the moment. So here's a much better path. This is a roughly 450 parts per million path, 2 degrees centigrade. If we turn around 90-degree angle on that line, more or less today, globally, and drive it down to zero emissions, or close to zero, then we stabilize at a pretty substantial amount of warming. I think it's harder to stabilize at 650 than at 450. That sounds counterintuitive, but here's a plausible path for 650. You still have to go to zero emissions to stabilize at 650. And it's harder to go to zero from a high point than from a low point. Economic dislocation is proportional to the distance that you have to go down and the speed with which you have to go down in your emissions. So on almost any plausible path, dilly-dallying around and waiting, and then trying to go to zero is essentially impossible, right? It's tough enough as it is. Okay. With all those physical characteristics of the climate problem, there then comes some things we can do to sort through on our way to solutions. And the first one is to concentrate on the big countries. The largest 20 countries have 75% of emissions. That's where we have to focus our efforts. If you count California, we'll give it the largest 21 countries. We're number 7, is that what I heard, or 6? 6 as an economy, that's pretty good. So that's the first thing. 185 nations get together for these UN gatherings. 20 really are going to drive the change. The second thing is there are 4 sectors, 4 energy sectors plus ag and land use. Transportation, electric utilities, buildings, and the grid. That's where the carbon dioxide is. So almost 80% of the carbon dioxide in the atmosphere comes from those 4 sectors. So if whatever your policy idea is doesn't drive one of those 4 sectors towards zero, you're not in the game. And so I sometimes get in trouble because I talk to people about their divestiture campaigns. There's so many tens of thousands, hundreds of thousands of students trying to get their university endowments to divest. It feels great. It sets a moral tone. I don't object to it, but tell me how it's going to change building energy consumption. Or tell me how it's going to increase the number of windmills put up. Coal-fired power plants don't shut down because of capital shortage. They shut down because we crush their demand with efficiency policies. You have to make these kinds of choices because our biggest constraint is political bandwidth. We don't have enough people pushing hard enough to flip the policies. Therefore, we have to get those that we do have to focus intensely on the ones that work the most. So on to these 4 sectors. I mentioned the grid, transportation, buildings, and industry. That's where the carbon is. That's where we have to flip. In the next point I'm going to make, so we talk now about the biggest countries and the 4 sectors. The next point I need to make is that policy is what is required. The world spends about $5 trillion a year on energy, and another $6 trillion a year on the infrastructure that sets future energy patterns. There is no way to create new money on that scale. We have to divert existing money from brown choices to green choices. We have to steer the creativity, the cash flow, the business models to these green sources, and that requires policy. So we've got 20 countries, 4 sectors, policy is required. We're narrowing things down. That's the idea. There, I just summarized what I was about to summarize. How about that? So what I'm going to do now is quickly walk through the 4 key sectors and talk a little bit about the technology options in each. They're richer than many people realize. And then which policies drive the change most rapidly? And it's a short list. We analyze hundreds of policies. There's a small number that make a huge difference and a lot that are essentially decorative. And I'm being a little bit hyperbolic here, but unfortunately not that much. Okay, so I'm going to start with I'm going to skip a couple slides here. I'm going to start with the grid. Everybody in this room, I'm certain, is familiar with the almost magical story of the price drops of solar PV. So this was laid out as a strategy in the early 1970s because people noticed learning curves. Learning curves are the closest thing we have to magic in solving the climate problem. And learning curves don't just happen. They require science, they require engineering, and they require mass purchase before the technology is cost effective. You have to have a deliberate strategy to bring prices down. But when you have a deliberate strategy, all kinds of things can happen. This one shows the cost of solar PV dropping 80% in just over 10 years. And lo and behold, as the costs go down, the volumes go up. Or as the volumes go up, the costs go down. Which is cause, which is effect? I don't care, as long as it's happening. Same thing with wind. This is onshore wind. Here's an even better story, offshore wind. Offshore wind has dropped in price by 50% in the last 4 years. Offshore wind is really a fascinating technology because it gets rid of sighting problems. You know, if you put these windmills more than 12 miles offshore, you can't see them anymore because of the curvature of the Earth. So you can solve the Kennedy problem. Nothing personal. I guess I can quote a Kennedy too. The wind blows much more frequently offshore. You get capacity factors north of 50%, some as high as 60%. You can put big things out in the ocean. It's easy to handle big things in the ocean. These big new offshore windmills, 10 megawatts each, 12 megawatts coming, are about the same size as the Eiffel Tower. Each windmill will handle all the energy needs for 8,000 houses. And then they're learning how to float them. So we can use them in California too. We have a very deep coastal shelf drop here in California, so you can't anchor them in the ground easily, but float them. So that's just one more example. There are others, let me go backwards. There are others, of course, with light emitting diodes, 95% drop in the last 4 years in price, and they work forever and they don't flicker, and you can tune the color. They dim, that's pretty neat. We're looking at heat pumps as maybe the next revolution. Advanced internal combustion engines, of course, what's happening with electric vehicles, batteries. So these learning curves are our friends, and deliberate policy will drive them. When you talk about a zero carbon grid, the first thing that comes to mind is, well, the sun doesn't always shine and the wind doesn't always blow, and therefore we have an intermittency problem. And at the extreme, and there are many people at the extreme, they say, well, we need a 100% fossil backup for every unit of renewable energy you deploy, because they might all turn off at the same moment, who knows. Or you need batteries in immense scale. Now, battery technology has come a long way, but we are not looking at anything like grid scale economic batteries. We can use them in certain sensitive parts of the grid, and they provide value, but we're a couple orders of magnitude away in price and performance before batteries become a big deal. That's okay, because I'm going to offer 5 other things you can do before you get to batteries that are cheaper and faster, and I'll go through these quickly. The first is improved operations. What does that mean? Well, San Diego and Seattle never have the same peak demand, and they never have the same peak supply. And there are wires connecting them. We just don't use those wires very well. If you start to hook up windmills and solar resources across the country, they smooth dramatically. Not a little, a lot. And not only that, demand smooths dramatically. So instead of 2 crazy curves you're trying to make work, you have 2 modest curves you have to make work. Why don't we have them? Why don't we use those operations? Because of silly parochialism. In California, we don't want Nevada and Wyoming controlling our grid. And in Nevada and Wyoming, they surely don't want California controlling their grid. But whatever happened to this capitalistic idea of comparative advantage? This is a simple problem to solve. The next one is demand response. What does this mean? I studied power systems planning in college and engineering, and we learned the following. Demand is whatever demand is. And you just keep turning on power plants till you've met them all, and then you turn them back off when you don't need them anymore. Turns out you can manage demand at an incredible scale very cheaply. What does this mean? There's a program by Nest where they, with your permission, adjust the temperature of your house a couple degrees, almost unnoticeable. And so when they need demand to soften a bit, they can dispatch your houses. And what does this cost? How much extra does it cost? Almost zero. If it's a hot, windless day in Texas, and these are things you know 24 hours in advance, pre-cool all the skyscrapers a couple degrees. Keep it within the comfort boundary, but then in the afternoon, instead of such a high peak, you're cycling them half as often. There are hundreds of demand response ideas that we just need to uncover. And these can be incredible contributors. Again, what does demand response require? A switch and a radio. Those are cheap. What does backup require? natural gas turbine or batteries or something like that. So we just have to deploy demand the same way we deploy supply. I'll give one more example because I love this one. It costs 1% as much to put in a kilometer of fiber optic as a kilometer of copper. Data centers are becoming huge energy users. So why not send the job up to where there's excess energy or excess wind? Why do we have to send electrons? Send work. Again, what's the price of that? 1% of the price of new supply. The next one is a time of use market. This helps both things. Right now, most energy markets clear on an energy basis instead of a switch onable, switch offable basis. I don't say capacity market because it's really about flexibility. It's about learning how to dispatch. If you send a price signal, entrepreneurs will do what entrepreneurs do. Flexible supply. What I say about natural gas now is use it for power, not for energy. If you run a natural gas turbine for 200 hours a year during those snowy, cold, dark winter weeks in North Dakota, or a blazingly hot summer when the sun's not doing its thing, when the wind's not doing its thing in the south, if you run that gas turbine for a couple hundred hours, the value can be dramatic, keeping the grid alive and happy, but the carbon footprint is negligible. It's when you run a gas plant for 4,000, 6,000, 7,000 hours a year that you get the big carbon footprint, but 200 or 300 hours, you won't even notice it. We need to build more grid, again, for the smoothing that was out there, and we need to do energy storage. The point of all this is if somebody is in charge of optimizing the entire system, if that's the job of either the ISO or the RTO or the utility, instead of just dispatching but optimizing with all these options, you can get up to 60, 70, 80% renewables, no sweat. And who will tell you that? Steve Berberick, who runs the California ISO. He's the guy that keeps the lights on, or he and his incredible teams. All right, which policies work? Really two for the grid. Very strong renewable energy standards or clean energy standards, and policies that value that flexibility I've just been talking about. That's what we need to do to get the grid down to zero carbon. The grid can happen much more quickly, much more cheaply than most people realize. And the grid is a fantastic enabler for the other three, because the easy way to pretend that the facile way to answer this question is make a zero carbon grid for your electricity and then electrify everything. Done. Not quite that easy. Let me turn now to cars. So what we said with cars is zero emission transportation or zero emission vehicles. This is short shrift, I admit. The thing one has to remember is we have to electrify transportation where possible and rapidly, and we have to pay a whole lot of attention to the future of the internal combustion engine as well. Because no matter how fast you think electric vehicles are going to prosper, we're going to have a lot of internal combustion engines. I think there will be, at a minimum, globally, 2 billion more internal combustion engines built and sold, no matter how fast electrification happens. So why do I think that? These are three curves of EV sales, not EV fleet composition. The bottom one is the Energy Information Administration. Doesn't like EVs, apparently. And then the upper two are my group, the Energy Policy Solutions Model, and Bloomberg New Energy Finance. We're going to take the most aggressive, the second most aggressive of those, the Energy Policy Solutions, and look at what happens to fleet saturation with this one. This is a very aggressive EV penetration. The gray up there is the internal combustion engines that are going to be out there, and it's the area of under those curves that matters. So we have to have incredibly efficient, incredibly clean internal combustion engines, even as we make that blue area grow rapidly. And there were great ideas already presented on that front. What does that mean? Fuel efficiency standards. Killer app. It's probably the single most important energy policy America's ever adopted, is fuel efficiency standards. They get asymptotic after a certain point. You know, after 50, 60 miles per gallon, you can start to relax. But look at the mix of vehicles we're selling. 67% of vehicles sold in America last year were SUVs or pickup trucks. 6,000-pound pickup trucks, 4,000-pound average weight of a car to carry around a 140-pound person, or more accurately, a 3-pound pizza, right? That's not a very efficient ratio. What can we do about the vehicle size? I'm going to rattle off some options. So one of them is, of course, electrify, but let's stick with the internal combustion engine, or either of them. Improve aerodynamics. You ever look at the bottom of an airplane? Smooth. Look at the bottom of a car. It's a mess. We're wasting energy pushing air. Look at the front end of today's pickups. They're really macho. Huge rectangles coming at you. Come on. Low rolling resistance tires, not magic. Big difference. Demassing vehicles, this is probably the most important. I get to drive a BMW i3. It's aluminum from my knees down and carbon fiber from my knees up. That car weighs 2,700 pounds, and it's stronger and safer and handles better than a lot of the steel cars out there. That's a huge opportunity for reduced auxiliary loads, LEDs for your lighting. More important, though, there are new paints that are the same color as old paints that reflect most of the heat, so your air conditioner doesn't have to be such a drag on your system. And then moving all your auxiliaries, instead of fan belt driven, to electric driven, whether it's power steering or heating or whatever. And then finally, we have to not let go of the engines and the transmissions and the drive lines, because there are fantastic opportunities in hybridization and so forth. The reason I put this up here is because if you hear somebody say we can't do it, remember they're the same people that fought airbags and seat belts and so forth. We can do it. All right. What are the policies that work? 2 of them. There's more than 2, but I'm being shorthand here. One is really strong fuel efficiency standards that get continuously stronger. Remember that word continuous, as in continuous improvement. The first fuel efficiency standard in America was signed by President Gerald Ford in 1974 during our oil crisis, our first one. It doubled fuel efficiency from 13 miles per gallon to 26 by 1985. And then it went flat and stayed flat until George W. Bush and then Obama doubled it again. What if instead of that one sentence, instead of saying 26 miles per gallon by 1985, he had said 4% a year improvement? We would have saved over $1 trillion that we sent to countries that hate us, and a commensurate amount of carbon dioxide emissions. And we would not have, in my opinion, bankrupted the auto companies, because they would have been innovating all those years because they had a target. So continuous improvement, which, by the way, the state of California has some of the best examples in the world on, which I'll get to in a sec. And then a zero emissions vehicles mandate alongside a really serious effort to build charging infrastructure. Make the utility the prime mover for building a charging infrastructure. We have to prosecute these pair of policies hard. Let me turn to buildings. How am I doing for time? Okay. Okay, no problem. Great. Yep, I'll even do less. So zero net energy buildings. I sometimes use these 4 zeros, right? Zero carbon grid, zero emission vehicles, zero net energy buildings, and zero waste manufacturing. In truth, 0 is not the right number, because that last 5% or 8% or 10% is really expensive. If we get down 80%, we leave our kids something to work on. It's not a bad idea. So don't get hung up on the 0, it's just easier to say. But we have to go pretty close, we really do. These low emissivity windows, I had the chance to meet the inventor of these a couple weeks ago at Harvard. You can tune them for the climate you want, and they act as clear insulation. It's pretty magical. So you can set them in a cold climate so that you have, every window is a net heater. Or in a warm climate, so they help keep your building cool. It's a simple idea. There's about 5 very simple ideas that make buildings work well. Great windows, great insulation, a little bit of thermal mass, a good overhang, and if you have the flexibility, the right orientation. Those are almost free. Buildings last 100 years. They're really hard to retrofit well, so get them right. How do you get them right? Building code. Who's got the best building code in the world? You're looking at it, California, signed by Jerry Brown when he was the youngest governor in California's history. And he put in it continuous improvement. It gets tighter about every 3 years. And the consequence of that is our biggest shortage, political bandwidth. We didn't have to go back to the legislature. We didn't have to get it reauthorized. Smart people at the California Energy Commission figure out what's cost effective, and they put it in the code. And they do it over 16 different climate zones, because the CRs are different than the Palm Desert. There's new technologies coming along too. This is just a schematic of a heat pump. If we're going to decarbonize the grid and then electrify everything, including the heating of buildings, let's be smart about it. Some of these heat pumps are now 4 or 5 times as efficient as an electric-resistant heater, and they're getting cheaper and cheaper. It's a pretty great bolt-on technology. It also heats your water and works as an air conditioner. Run it backwards. So there's my LED chart. That's a learning curve for you. Appliance equipment standards. California has led the way on making the plug loads in your house much more efficient. This is Art Rosenfeld's inspired slide with energy consumption in refrigerators dropping 80% even as the price went down and the volume went up and the reliability went up. And that was because of energy efficiency standards for appliances. If you give manufacturers enough lead time, if you employ continuous improvement, if you liberate them to figure out how to get there, they will do it. They will do it. You can always back off if you need to, a little bit. But if we're timid about the standards for efficiency that we are willing to set, they're going to be timider. No one's going to reach out past us. I'm going to go a little faster. So the killer app for buildings is a great building code and great appliance standards. Again, California's example is fantastic. Norway has a great example too. But the United States building code process is a minimum of a decade behind what's feasible. And even the best building codes that the United States promulgates are kind of crap compared to where we ought to be. Okay, I'm going to go to the hardest sector now, which is zero waste manufacturing. This is hard because manufacturing is heterogeneous, because it employs trade secrets, because the capital costs are huge and capital stock turnover is slow. So again, the way to do this is to neck it down as much as you can to get to the big stuff. And there, I have to put on my glasses here to read these. There are about 6 sectors that really matter: agriculture, iron and steel, chemicals and plastics, cement, and then the energy business itself. That's where most of it is. A large fraction of emissions from this sector is not CO2, it's the non-CO2 forcers, like methane leaks, especially in ag and oil and gas extraction. It's easy to stop methane leaks in the oil and gas industry. Thermodynamics is a really hard science. Chemistry is a pretty hard science. Plumbing, come on, that's what it is. Just don't let stuff leak. Better plumbing. I think we can handle that. So that's what we have to do for the biggest bar up there. And the way you do that is with a standard, a close to zero tolerance standard for natural gas leaks. And you can use remote sensing, whether it's satellites or drones or airplanes or in the field sensing to monitor that. Then there are generic industrial technologies like motors. 45% of all electricity in industry is used in motors. And the way most motors are controlled in most industries is with a valve on the pipe of the whatever the motor's pumping. This is the thermodynamic equivalent of putting a brick on your gas pedal and adjusting your speed with the brakes only. Instead, have a variable speed motor and have some sensors that talk to each other. So when you turn on a valve, you're not physically throttling it, you're electronically controlling the speed of the motor. It's a simple idea. It saves an enormous amount of energy. It's the kind of thing we need to make commonplace, normal, instead of exceptional. And then finally, there are some sexy new technologies. I've seen a cement 3D printer printing houses in China. If complexity is free, material waste can plummet. I think I might have a picture of a bridge in here. Let me see. Yeah. So if you think of a normal bridge made of concrete, it's a rectangular slab. The stresses inside that slab are uneven. They're all on the top and the bottom. Most of the mass, and remember, cement is 5% of global CO2 emissions. Most of the mass in that bridge does nothing. But it's way too expensive to put concrete exactly where it matches the stress lines if you're trying to do it the old-fashioned way with forms. So do it the newfangled way with printing. Print that damn bridge and cut your materials use by half or more, and with it, the energy use. Print your houses. There's almost no innovation in houses as a complex system. There's innovation in devices. We need to start thinking about system optimization as a principal strategy. The policies in the industrial sector are more complex because they're heterogeneous. Carbon pricing actually works pretty well in industry because industry is deeply price sensitive, especially the big industries operate on small margins. Steel and concrete have terrible margins, and that's some of your worst. So use the carbon pricing. Efficiency standards for devices, and then carbon intensity standards like, here we go again, buy clean in California. When the state of California buys concrete now, they have to buy from the top quintile, I think it is, of carbon efficiency, of carbon content. So that's a nice way to go. All right. I'm going to wind up with a conversation about how we get these policies in place. And I'm going to use my next -1 minutes to get that done. Sorry, I'm getting close. The first thing is obviously focus on the big countries and the big sectors. And by the way, it's almost always national policy or state policy. It's not a United Nations convention. No matter what they signed in Paris, if it doesn't come home and affect building codes and fuel efficiency standards for cars, it ain't real. Paris doesn't save America. The California Air Resources Board saves America. So choose well. So now we have to look at precision intervention. If our biggest bandwidth issue is political capital, let's deploy it brilliantly, not in a big fuzzy way. So I'm going to give a little example from the Public Utilities Commission world. So half the carbon in the US economy goes through monopoly pipes and wires. Because they're monopoly pipes and wires, natural gas and electricity, they're controlled by the Public Utilities Commissions in each of the 50 states. They're not controlled by Washington. So 50 state Public Utilities Commissions. Each Public Utilities Commission has about 5 commissioners. So there's 250 individuals that control half the carbon in the country. And they operate in a quasi-judicial way. They have a statutory framework. They consider evidence. They have goals goals established, public goals they have to meet. They make decisions. They allow testimony. It's like they've laid it out for an intelligent intervention. You go in there with an ethical argument or a technical argument or an economical argument, they will listen to you if you pay attention to their rules. So 250 people. But it's even better than that because 30 states are little. Skip them. We're now down to 150 individuals. But we don't need 5-0 votes. Let's go with the 3-2 vote. We're now down to 90 individuals that control almost half the carbon in the economy. And they're paid to listen to you. Same with building codes, same with tailpipe regs, same with fuel efficiency standards. It's a small number of people, most of whom are meritocratic, not all. I can name some exceptions. Sorry, I won't go there. And so if you focus your energies and your time and your ethos and logos and pathos on those people in their forums, you can affect these big systems. And that's the way we deal with climate change. Thank you. Go to the closing slide. There we go. Thanks.
Thank you. Why don't you go ahead and stay up, and why don't I have Barry and John come up as well. And as they're coming up, I'd also like to take an opportunity to say we have 2 additional winners that weren't able to be with us this afternoon, but I would like to introduce them. And tomorrow we'll meet one of them, and another sending a representative. So Dr. Paul Crutzen, who is recognized for his international air pollution research out of Germany, I believe, and Dr. Ann Douglas, who is being recognized for her contribution to atmospheric science. So we do have about 25 minutes here. We have some brilliant people and brilliant people in the audience. So let's start a conversation. I think that we've heard about the research. We've certainly understand the policy and the way the policies have changed, and we've been stimulated with great ways of thinking about solutions. And so, what kind of questions do we have? And so I'll start it out while you're thinking about it. And really, that's okay. I think I'm talking loud enough. Okay, so I will start out. And Barry, I'm going to start out with your observation on how things are going to change to address the equity and the environmental justice areas, but also going off on your thought as when we are able to stop the emissions, we still have the accumulation. And I think that's one of the critical issues that we have within the equity communities is that accumulation, the cumulative effects. And so from a research perspective, from a policy perspective, and looking at solutions, what observations would you have on this changing landscape to focus from a regional down to communities? John, do you want to start from a research perspective?
Well, I think, as Barry pointed out, there's a lot of newer technologies now that we have to be able to quantify what these are. The big problem that I tried to point out was that a lot of these types of pollution sources are kind of fugitive. They're just kind of spread out. And so this is why we need better spatial and temporal coverage for those. And I think Barry's making some good progress on that work in terms of trying to couple that with particularly decision-making, which also requires a more rapid feedback into the system.
So when we were talking about the sensors and things, the technology advancement like John was mentioning, in the past when we've tried to get to things like cumulative impact, we've mostly been dealing with emissions inventory. And the scale refinement isn't enough to be able to know there's a particular facility that's driving, let's say, risks for a good segment of a community. That, in my mind, is about to change. And so once we have these tools, we can really prioritize where the efforts need to be to maximize the benefits to the community. I'll mention one, and I know I'm on the internet, so hope it doesn't appear in court or something of that nature. But in South Coast, we have had, and there still remains, issues with a large lead battery recycling plant, Exide. The way that that issue came to us, even though we were doing periodic inspections of the plant, was there was a person working across the street who didn't like the dust on his car. I had a hexavalent chrome issue in Riverside, and it was the community next to the cement plant that, again, complained about the dust on their car. And so, you know, the eyes and such of the community members as community scientists is really important, but we have to come back around with the scientific work to really define the nature of the problems and what is most significant. And it's, I think, going to be a totally different world on data collection, processing, analytics, and then using that to derive the solutions.
Well, first, I want to pay homage to scientists and people who do the hard work of cleaning up the clean air here. And there is a continuum with everything we discuss. I sometimes feel like I'm a full-time mouthpiece for the California Air Resources Board because there are 0 other agencies in the world with the resources and the drive of this agency. And it's a model in China. I've worked with Michael Walsh and others in China for many years. They have maybe a dozen people to try to do what a few thousand really credentialed, brilliant, driven, dedicated people can do. So Barry, John, thank you for that. It's really important. There was some discussions about democratizing data, not using those words. I serve on the board of a foundation in London, which is paying for every school in London to have a very sophisticated air quality sensor and to network them together and to send home reports, right? So when you get your kids' report, you're going to get a school air quality report card as well. And guess what that's going to do, at least we think? Change the pressure a little bit. So as data becomes cheap to obtain and cheap to manage, you can create a new political signal. Part of that then is how you deploy things in the world. Where should electric trucks go? What should electrify first? Delivery trucks, garbage trucks, and buses. Why? Because they run 50% of the time instead of 5% of the time, and because they create exposure. It's a product of time of use times emissions rates times exposure. And so if you put those things together, you know where your ARB subsidy should land, right? And that takes the kind of science and deployment that these gentlemen on my right and left know how to do. So.
Maybe even 2 questions. One for Barry. You brought up the need to address communicating science to not only the public, but to something that some of us worked on for decades. I worked with Steve Schneider, the late Steve Schneider, on this subject for years, and that is communicating scientific findings to policymakers and how to do that. I thought we did pretty good for a while. based on the world I live in today, it looks like we're not doing too good, at least in this country. What do you see happening to address that? And if I may let Hal think about something for a minute. I thought it was rather courageous of you to bring up the subject of internal combustion engines in this building. And yet I agree with you that that's a reality. And how do we get people to focus on the fact that besides just dedicating ourselves to electrification, there is a need to look at the rest of this pie and to take some actions and recognize, like it or not, they're there, and we cannot not address them for fear that they may interfere with the prime objective, which is electrify everything.
So in terms of communicating with the public, the science, again, it's, I think, been hard to personalize the issue of climate change until more recently. The huge fires that we had and the tragedy of it all and the loss of life has personalized that issue for a lot of folks, as have some of the things that Hal was pointing out, where you can actually see the effects of climate change and start to distinguish. It wasn't some odd one-off event, but there are trends occurring, because we have to, again, translate, for example, the chart that Hal had about the accumulation and the long lifetime. We're so used in traditional air pollution that the wind blows the pollutant, it diffuses, or the rain washes it out of the sky. That's not the case anymore. And so to get down to the individual resident and in millions have everyone really understand that is a huge, huge task that we have to use the modern tools to be able to accomplish. I'm actually hopeful that we'll make that transition on one hand, but on the other hand, the South Coast District recently had some polling done and asked, the people that participated, do you know who the South Coast Air Quality Management District or the AQMD is? And then also asked about CARB. And, when you're getting numbers about down in the 10%, that's not a lot of recognition for the people that are scientists, credible, trying to work the issues. Now, right now, if you ask people about climate change, I think they'd say, oh, the fires, the flooding, the melting ice. So we have to, the last thing I'd say is, in thinking about this, for cigarettes, we saw public service announcements on TV that shook you up. Have we really translated the message in that kind of strength for climate change? I don't think we have yet, but I think we need to.
I think there was a follow-up question for you, John.
No, I think it was for him. Well, but it actually plays to both of our talks. The Air Board, probably more than almost any agency on the planet, is science and quantitatively driven. And so how do we keep attention on internal combustion engines? Math. And I know that sounds like a boring answer, but go try to buy a really super efficient 3/4-ton pickup truck or Class 8 truck, or, we're making them by the millions every year. There's over 1 million Ford 150s sold every year already. It's going to take a while before those new guys swap them all out for electric. So it's not sexy, but neither is ammonium nitrate, and we're doing a good job with that.
Well, I think the key thing here is kind of the synergies, that you get a more bang for your buck. I mean, everything you talked about is going to improve the air, as well as, the immediate air. And really, there's a lot. I think the communication has to be, while it may seem complex, is this multiple source, multiple pollutant, multiple effect. And multiple effects is important too. Some people are sensitive to stuff on their car, the cement dust or whatever it is. Others to visibility. Certainly people with asthma are sensitive to health effects. I know in China, one of the big motivators was the picture that Judy has in here of her with the terracotta warriors. Not only is that a treasured cultural artifact, it's a big moneymaker. So I think there's a lot of ways to kind of get to people, but it's kind of individualized.
Let me just add one more sentence. Back to the communication one. I think public opinion is reaching, I hope it's not a crescendo, but a new high right now. There are a lot of people, Rs and Ds alike, who want to do something about climate change and recognize it as a real problem. I think our challenge is to channel that inchoate energy into focus-specific solutions. That's what we have to do. And that requires a kind of knowledge, but also a kind of political realism. And it requires some tricks. I don't mean tricks in a bad way. I mean tricks in the good way, like continuous improvement, right? If we pass laws, put in a rate of change rather than a new plateau.
We have, well, not me, but the state has considerable experience in dealing with air quality, almost 100 years of research, development, and deployment. But climate change is a more recent problem. And fundamentally, to some extent, these are different issues. Air quality is local or regional, but climate change is global. Do you think, are we being held back by the same strategies that were used for air quality? Are we trying to translate those to climate change? Or in other words, how should policy be adopted from the past experience to dealing with climate change? To some extent, how would deployment and research be modified? And then my second question is, how do you make sure that one of these is not left behind because they may not be mutually compatible? Sometimes EJ communities may feel that a lot of emphasis on climate change means the air quality is not being tended to.
Who wants to start on that one?
Well, in terms of the communities being left behind, the difference now is the fact that these communities are going to have community-specific plans. And as I mentioned earlier, we have experience in setting requirements in place either through permits or regulations that in effect are community-specific or situation-specific that would be applicable to multiple communities, those building blocks. In terms of the strategies, I personally believe that a lot of the old, and not old, a lot of the strategies we use in the toolbox today are applicable to climate change and can be enhanced or modified, like remodeling a house. You don't have to throw the whole thing out. You can make some strategic changes and they'll be applicable.
Hello, John.
Well, I think one of our biggest impediments is our state implementation planning process because it's single pollutant. Okay, we're going to deal with ozone this year, all right? Oh, now we're going to deal with particulate matter, but we deal with them separately. And now we're going to deal with climate, even though it doesn't require a SIP. So we really need to kind of get that unified together. So that's where I would say we need the biggest policy change is to relook at this whole planning process, not in terms of the federal state implementation plan, but in terms of planning for all these and then kind of looking for the optimum solution.
Those are great points. I'll just try to add a couple. The first thing is we do have to recognize you can often solve one problem and neglect the other because air pollution is mostly chemistry and climate change is mostly thermodynamics. And I say mostly because they're not entirely. And chemistry is much easier than thermodynamics. Thermodynamics gives you 1% in a very good year, right? So, now there have been political efforts to purposefully keep them smushed together, and it's an explicit policy of the Chinese government to try to solve them at the same time. Because if you co-optimize, you're going to do a much better job than if you optimize one at the expense of the other, which we've done in America, right? We've optimized pollution at the expense of fuel efficiency for years. There are a number of solutions that do both, and they're pretty brilliant. Energy efficiency, right? You're investing in your community, it reduces criteria pollutants, and it reduces greenhouse gases. Non-CO2 forcers, methane leaks, volatile organic compounds, greenhouse gas emissions. I think one of the most powerful political ideas you can have is reinvesting the proceeds, as we do in California, a significant fraction, more than half of the proceeds from selling carbon permits into community rehabilitation. We need to take the most abstract problem on the planet, it's invisible, it's global, and it lasts for centuries, and turn it into the most tangible thing on the street, right, which is bike lanes and clean transit and quieter streets and more pedestrian accessibility and greenery and that kind of thing. If we don't let those benefits be visceral as well as global, then the political force behind them will attenuate.
Now, Barry, before we leave this conversation, you have often talked about a portfolio, a suite, how to look at these challenges and between the regulatory aspect, the incentivizing, and behavioral changes. Can you speak a little bit to that?
It most definitely needs to be a suite of measures, and the balancing part as to how much you do by incentives or command and control, and how you select between options within categories is really critical. As Hal's mentioning, a good part of that also gets down to political will and political influence. And so we need to do a better job, frankly, of managing that aspect. And I'm hoping that as climate change, picks up some additional momentum, communities being addressed in terms of environmental justice, that we're going to get enough political push and pull that it'll help us sort that out better.
Thank you. Another question. Hi, Bart.
Hi. Thank you for 3 very interesting and inspirational talks. Hal, I had a question for you. So does your emission and policy analysis include all the short-lived climate pollutants and things like international shipping and aviation that can be a significant part of the footprint? And then my second question is, if you could give a couple more examples of how to affect this political bandwidth in some of the other countries that you pointed out.
So, if you really want to dig into our analysis, you can go to energypolicy.solutions. And we've developed a very detailed systems dynamics model of the U.S. energy economy. We've done it for China, India, Indonesia, Mexico, Poland, and one other country. And we've just done it for California. It's the first time we've done it for a subnational actor. It's a bottom-up model. It's a replica of the physical economy. And it's a difference engine. Looks at BAU for every single thing, and then how policy would change it. So it's got 50 different policies is what you can adjust with a slider, and in real time it shows you conventional pollutants and CO2. And so that's the answer is we have gotten into those other sources. I mean, aviation is growing the fastest, and there's no ready substitutes. Shipping, there are some actually pretty fantastic opportunities to reduce pollution. Cement, too, there are some great opportunities. So these require a much more precision approach than a general conversation, but there are big opportunities in almost every sector, cost effective.
Could I just mention that with the changing demographics, we have significant change in representation in state capitals and in Congress. And when we talk about communities and environmental justice, there is a much stronger voice today than there was in 1997 when I started working on policies at the South Coast District in that regard, because you have more members and you have more power in terms of committee chairmanships or being leaders in their house. And that's why we've seen some of the change that we've seen, and I think that that's likely to just continue to gain momentum.
Yes, in the back here, please.
Thank you all for great talks. It was very stimulating. I have a question kind of on the idea of point of regulation and kind of what technology enables our future to look like. So right now, a lot of policy is focused on like industry, gas, and rather than the user. But when we're talking about like automated vehicles and there being tracking devices in your vehicle itself that tells you how much you are emitting. So I guess my question is kind of if you see any benefits, pros and cons maybe should we be shifting our approach in who policies are targeting? For example, maybe because part of the reason why climate change is not individualized is because even though people pay essentially a gas tax, they don't realize that there's a connection to climate change because it's an invisible message. So that's my question.
Well, I'll tell you one thing I've always believed here is that, and I think this is going to be a problem too, because when you have electrification, you don't have a gas tax. So I've always kind of thought with the technology, when you go get your car registration, it ought to be at least proportional to how much you drove it. And maybe even if you have some kind of a sensing like you're talking about, how much pollution you emitted, so that you actually do put a price on this. And I think that is probably, wouldn't you say that's one of the more successful ways to go about this? You mentioned that in your presentation, is to put a cost on it, put a real cost on it, which we're not paying now.
You need feedback loops in order to be motivated to do anything. I guess here's the, let me add an asterisk or caveat to that, however. There's tension between the idea of the green consumer and the green citizen. So the green consumer buys a Prius and uses recycled paper towels and eats fish-friendly fish or whatever they're called. And the green citizen lives in a world with great policy where things are getting better all the time. And in fact, you need the latter, right? Because most people will not spend most of their time trying to do the right thing. It's typically around 5% of the population that is really earnest about it. However, the right kinds of feedback signals can be useful, and having those 5% out ahead of everybody else creates the industries, the technologies, the social practices, the businesses, and the precedent for what then can become public policy. So you can think of it as a lever and a pawl on a ratchet wrench. There's a powerful use for it, but never think of it as a substitute for public policy.
So let's close our conversation on our citizens. This world is going to look a lot different. We're going to behave differently in it. It's going to have a whole new energy source. The way we interact with energy is going to be different. So how do we get citizens more engaged, and what signals and what education and what outreach do you each see are critical to start that path forward?
I mentioned a few of these in the presentation. What I've found remarkable about doing some teaching over the last couple of years is I go into the classroom with the students and I can show them the old picture of Los Angeles. They don't relate to that. So we have to think about who we're reaching out to and make sure that the materials relate to their generation. Just as those of my generation didn't fully realize initially what a cell phone was going to do. But to a young kid now, they know all the stuff it can use. And my 2-year-old granddaughters play with cell phones and actually can operate them and watch videos, which is a little scary. So again, it gets down to personalizing it. And I think one thing for me was when we had these terrible fires, I have 2 children live in San Francisco, and they're all rushing out to get the right kind of mask because their father's a scientist to wear because the particulates are so high and resemble what you see in China or something, right? So we have to think about that imagery, and they communicate over the internet with their cell phones, with Facebook and Twitter, and watch YouTube videos. And that's why I have no idea what you've done as a board or Richard, but I think you ought to really hire some top-notch communication people that specialize in that kind of communication and bring in the people from those companies and try and work out some deal so the cost isn't prohibitive. That's what I would do.
Great, thank you. Hal?
Just a couple of ideas. One is what I said before about making it visceral. Let's make sure communities, especially the most polluted communities, see improvements in their day-to-day lives right in front of them. You know, the first 500 electric trucks coming out of Port of Long Beach should go through the worst parts of town, right, and be quieter and less polluting. The other thing, though, is there's real power in a clear vision. You can't expect every citizen to understand the chemistry that John does. But if you say, California's going to lead the world, and we're going to zero on all four zones, and we're going to have hard interim targets along the way, and we need you to be part of it. And one of the things I always ask people is, if California doesn't lead, who will? Right? We have the science, we have the institutions, we have the political will, we have the technology, we have the money, we have everything. And so if we don't drive to zero cost effectively and rapidly and publicly, who do we think is going to do that? Iowa? I don't know.
Well, I like Barry's idea of getting more into the schools, and particularly in elementary schools. And it kind of made me think about when we had the first wood stove regulations in Reno and the burning bans. We put together some units for the teachers on how to do it. And it was the kids that would say to their father, hey, you know, it's a bad day. You can't burn this way. I mean, people think their wood stoves are like their guns. I mean, you're invading their privacy with these things. And so I feel that's a very important aspect, because honestly, I think we're not getting people to think environmentally, and I think it's got to start young. And I like your idea, or what you mentioned they're doing in Britain to get people involved in that. So I think these are the efforts, and you've done a great job with that down there, Barry. I've looked at your website. You got, or what used to be your website, and you got some really good stuff there.
Last question. Are you bullish on the future and the opportunity that we're going to resolve these problems? And if so, what drives that bullishness?
I have to answer honestly. So the 50-plus year history makes me continue to be optimistic about local air pollution, whether it's at the community level or the regional level. Because we continue through policies and regulations to push technology that gives us options that we didn't envision. Things today, when I was here on the CARB staff in 1982 and you asked us, would we get motor vehicles down as clean as they are? Well, we would have probably shook our heads and said, I don't think so. But that's caused me to be optimistic about that. The climate change is a different deal. And it's that photograph that was part of my presentation with the sand running through the hourglass. And so I'm less optimistic that the response is going to be in time, not due to CARB or others not, and Hal really working it and trying, but there's so many people that have to be convinced, and so many different circumstances, comparing a California to a nation in Central Africa or something. But he's got that short list of countries. The question is whether you can get everybody to worry, this is my last point, worry for 2050 or 2100 when they're worried about putting food on the table and a roof over their head.
Al, I'm going to save you for last if you don't mind. John, I'm going to have you go.
I'm pessimistic. I don't know. Maybe people are getting stupider, but there's too many people that believe absolute falsehoods, even when the evidence is placed in front of their faces. Maybe even in California, there's people like that. So I'm concerned. I mean, I never thought it would be this bad.
And I appreciate that. I wake up that way, feeling that way myself. Al?
Optimism is a social change strategy, right? And if you believe you can get something done, there's a chance you might get it done. And those 4 zeros I laid out, they're all attainable. We have technology tailwinds. We have economic tailwinds. Our political tailwinds in the states are pretty strong. We have tailwinds in a lot of other countries. Michael Walsh here has been to China more than me, but I've been 70 times. And the reason I keep going is because they are really eager to do the right thing. They have a deep, deep hole to dig out of, too. Mike, you're still optimistic, I hope? Yep. So engineers are optimistic. Yeah, I'm not going to argue that it's a simple. There's no simple answer to this, but there's a huge difference between being smart, being focused, and trying hard, and giving up.
Could I just mention, because I said I'm not as optimistic, I don't want to come across as being, overly pessimistic either. When I was at the South Coast District and joined the agency, we had Professor Larry Corretto on our board, a professor emeritus from Cal State Northridge. And I was sitting there listening to a policy debate, and he made a very simple statement that here I am 30-some years later. It stuck with me. He said, before he voted, I'd rather aim high and come up a little short than aim low and not achieve what we otherwise could have. And I think climate's that way, as Hal was describing.
And John, I think from your perspective, you keep up on the research because there are smart people that continually try to find these solutions, and we're going to pray for the rest.
Let's do it.
Thank you so much, everyone. Really appreciate your time. And congratulations. We'll look forward to seeing you tomorrow, 9 o'clock in the Byron Shear Auditorium, and have a great evening.